Hello guys, I just want to take a few minutes here and go over a couple of things, how I created my library feature part for my threaded fasteners or threaded parts. So what I did was create my library feature part. So let me just bring up my unified thread sketch here. And basically I cut this down to the absolute minimum necessary to define the size and shape of the thread. So I've got some equilateral triangles here that give you a 60-degree angle, and then my pitch is defined accordingly from point to point, and then the crest and valley or crest and root are defined based on the pitch, either by 1/8 or 1/4 of the pitch. And looking in the equation editor, I added a parameter in here for threads per inch, and then I have my pitch as 1 inch divided by TPI, so that defines the size of my sketch when it's inserted in the part. Now for the metric threads, basically it's the same profile, except in this one because thread pitch is defined in the thread size directly, you don't have to have the TPI and go through the conversion, so you can just enter pitch directly in the equation editor once you insert this in your threaded part. So in this case, it's like an M12 1.75 pitch would fit this particular size thread profile. But again, it's just pitch and defining the root and the crest of the thread profile. So let me bring up a new part here, and I'll just start a sketch here on here. We'll say 0.190 and extrude this to 1 inch, and then we'll bring in our unified threads. Grab here our unified helical cut threads, and we'll put it on this plane, and then we'll come down here and grab it with the 4-way arrows, drag it up to the end, and apply this, and then close. Now, first thing you want to do is open up the equation editor and find the TPI, and Alibre is going to append the values on your library feature parts. You're going to put another number on the back end, or like a D number or an S number. And in this case, TPI for this number 10 is going to be 24. So we'll enter 24, tab over to updates, and OK that. And now we'll edit the sketch. And I forgot to rotate this. So let me see here. We can come up here and do a sketch rotate on this. We'll center it here, angle 90, and apply, and it could not be rotated. Okay, so forget that. So let's try this again. We'll delete this, go back up to our library, grab our library feature, unify helical cut, bring it in, grab this plane, and now rotate 90 degrees and move it into position, apply, and close. Now let's double check the equation editor. And now, because I have two of them here, the newest one is going to be S6, so I want to change this to 24. And OK that. Now we can edit the sketch, and we'll do some constraints here. We'll put this point coincident to this edge, and then this line coincident to this point. So now this is going to be the major diameter. And now we'll go into our helical cut tool, and for axis we'll select this axis. We'll change this to reverse direction, change our height to 1. And now for pitch, we'll click on the FX button and go into the equation editor, select our pitch parameter, and OK that. And just like that, you've got a threaded part. The only thing now, you'd have to add some fillets on the end of this thing to clean up the ends of your threads, but that's basically how you create the threads on a threaded fastener. Now, if you're going to do this with a where you add threads as a helical boss, then you necessarily have to start out with your boss part sized to your minor diameter, and then you would add your sketch, add the sketch on here and rotate it as a helical boss rather than a helical cut. So, and the same process holds true with the metric threads too. So let me, there's one other thing here, because at the end of your threads it just kind of ends abruptly, and if you want that to, let's change this to 0.75. If you want this to lead out like a normal thread would be, so you start a sketch on this face, and then select it, you project sketch normal figures and maintain association, and then you go back into your helical cut, and your axis will be your central axis again on a reverse direction. And here we'll just change our height to 0.1 roughly, and again our pitch. We'll come in here and we'll find our pitch, select that, and OK it. And now to make it lead out, we'll put a taper angle in here about 60 degrees. And there you go. Now your thread is has a nice run out on the end where it completes. So at any rate, that's kind of the quick and dirty on how to do threaded studs. Let me bring up another part here. I'll do a internal thread. So we'll start a sketch here. Say make this 0.5, extrude this 0.5. Actually, yeah. Now for this, we need a hole to put threads in. So what I normally do is start with my thread, or my hole part, or tool, my start surface here. And here, if I'm going to do a coarse thread, and I'm going to use, say, 1/4-20, and I'm going to do this through all, and place that hole. Now here I'm going to leave this source as minor diameter, and then we'll OK that. Now the alternative would be, of course, putting a hole in here as sized to the minor diameter of your thread. So now let's go into the library and grab our insert library feature, and we're going to do another helical cut. And we'll place it on the XY plane, and we'll find out where it's at. We'll bring it up, rotate it 90, apply and close. And now here, again, this is going to be a 1/4-20. So, okay, we're already set at 20 on our part, or feature. So now we can edit the sketch. And again, we'll constrain this. Put this point down on that edge, and then this line on this point, and now go back into our helical cut tool, grab our axis, change our direction, change our height to 0.75 so it goes all the way through, and then our pitch. We'll come in here, we'll grab our pitch parameter, and well, we probably didn't have to go 3/4, but that's fine. But now we have our threads cut in there. So now if we look in here as a precise section, we'll reverse that. And there's And there's our 1/4 threads cut through this part. So there's kind of the quick down and dirty on how to use the library feature part for creating threaded parts. It could be fasteners or studs or standoffs, whatever. And if you want them for a show, that's great. If not, the only thing that these don't do is allow for any clearances. So right now that minor radius or major radius is 125, so that's a radius of or diameter of 0.25, so that comes out to the right size at 1/4 inch. So you'd have to take into account for clearance and tolerance as you create your parts using this method. So with that, let me close that. So hope this helps you out. I know that library feature parts are only a function in Pro and Expert, so maybe this will be an incentive for anyone that needs them, needs to have these features. Will maybe upgrade, but otherwise you're left creating all these features manually in Atom or Workshop. So anyway, thanks for watching. Talk to you later.